Welcome to the WealthKode blockchain knowledge series, and in this episode we'll be talking about Flare. Remember to follow and subscribe to our pages for all future episodes being released on a regular basis. And of course, if you'd like us to delve deeper into any of your favourite blockchains, cryptos or digital assets for future episodes, or you have any questions at all, feel free to drop a comment. So let's get started. The rapid growth of interest in using smart contract platforms like Ethereum for decentralized applications, particularly within DeFi, has necessitated the development of more scalable and interoperable protocols that can handle the volume of demand without causing bottlenecks or high fees. Proof-of-stake consensus protocols have become increasingly popular compared to power-intensive proof-of-work systems like Bitcoin, whereby a native token is locked up in a staking contract to secure the network in return for an incentive reward. The trouble is, while proof-of-stake can increase throughput as the native tokens on these networks are being used for security, it limits the utility available to proof-of-stake protocols where competing uses, such as decentralized finance, can cannibalize the safety of the network, limiting the scalability of value. This is not a desirable outcome either, making it more of a stopgap than a long-term solution. As a result, around 75% of the value held in crypto tokens still remains inaccessible to decentralized applications, a situation that needs to change to meet existing demand, let alone that of the future. Contrasting existing protocols, a new generation of smart contract platforms are being built using specially adapted networks that are scalable without needing to rely on the native token for security, providing greater flexibility in its potential use cases and unlocking otherwise trapped value in the crypto ecosystem. Flare is the world's first such network, capable of scaling smart contracts and enabling trustless interoperability with a variety of other blockchains or distributed ledgers at low cost and high speed, starting with XRP. In this video, we'll explore what the Flare network has to offer, how it works, how it can be used right now, and what comes next. So, what is the Flare network? Flare is a distributed network running a version of the Avalanche Consensus Protocol adapted to work by Federated Byzantine Agreements, FBA, and integrated with the Ethereum Virtual Machine, EVM. But what does that actually mean? EVM integration means the network can run what are known as Turing-complete smart contracts, like those deployed by decentralized applications in the Ethereum ecosystem. The FBA adapted Avalanche Consensus Protocol works similarly to the XRP ledger or Stellar, without relying on economic mechanisms like proof of work or proof of stake to secure the network. Instead, each computer node running Flare uses what's known as a unique node list, UNL, which is each node operator's private definition of other network nodes they voluntarily choose to rely on for consensus. As a result, Flare's native Spark token, FLR, is freed up to be put to other use. On top of this, Flare has built a secure F-Assets protocol for the issuance, usage, and redemption of tokens, initially for FXRP as a trustless one-to-one representation of the XRP token on the Flare network. It enables holders to use full Ethereum-style smart contracts with the wrapped XRP token on Flare, without relying on a centralized third party, opening up the potential to use it in a real DeFi applications like Uniswap. Other F-Assets like FXLM and FDoge will also be integrated over time, including support for FLTC on launch, with Flare able to theoretically connect to any token from any chain, concentrating liquidity on a platform with large sources of value that are now compatible with each other. The same system underpinning the F-Asset protocol, called the State Connector, allows for the issuance of assets from Flare to other chains that support non-native assets. For example, the issuance of FLTC onto the XRP ledger, enabling trustless cross-chain interoperability. The combination of these properties allows for the scaling of smart contract networks, the unlocking of the value of all tokens, and the creation of a trustless interoperable ecosystem of decentralized applications with F-assets, also propagated across interoperability networks like Cosmos or Polkadot, as well as Ethereum via well-defined bridge protocols. The Spark token, FLR. Spark, FLR, is the native token of the Flare network. Like other networks required for spam control to avoid congestion from useless transactions, Spark will be created through a utility fork whereby the origin network, in this case the XRP ledger, benefits through increased utility, with 100 billion tokens created at the outset of the Flare network. Beyond this, FLR can simultaneously be used in the network as collateral within decentralized applications, as a reward for providing data to an on-chain oracle called the Flare Time Series Oracle, FTSO, and to enable participation in the governance of the protocol. These functions do not compete with one another. Combinations of these three components form the building blocks of applications that can be built using Spark, known as Spark Development Applications, or SDAs. As the network does not require staking or computational returns in FLR, the FTSO becomes the inflation function for Spark tokens. It's the FLR collateral on specific SDAs that allows for the trustless issuance of F-assets as representations of other network tokens, including those that don't natively support smart contracts, like XRP. How does Flare work? To put it simply, Flare relies on participants who provide FLR as collateral and earn fees during the creation and redemption of F-assets to be used in smart contracts, paid in those F-assets. This incentive, alongside potential arbitrage opportunities, ensures a one-to-one peg between the F-asset representation on Flare and the underlying asset is maintained. FXRP. Let's use the example of FXRP to explain how the process works. The FXRP protocol safely allows an XRP holder, called an originator, to send XRP to a set of addresses, called agents, on the XRP ledger at a fixed fee of 0.1%. FXRP smart contracts on Flare then issue FXRP to the originator, convertible one-to-one with XRP, and secured by locking Spark tokens as collateral from the agents. The collateral ratio for FXRP is 2.5, meaning that at all times agents must have provided 2.5 times the value in Spark tokens compared to the FXRP issued, using the Flare Time Series Oracle, FTSO, for the XRP FLR price, and Spark token holders for governance. Conversely, FXRP token holders wanting to redeem for XRP, a redeemer, send FXRP back to the FXRP smart contracts on Flare, and the agents then send XRP to the redeemer's address on the XRP ledger. If this is not done quickly enough, the redeemer is automatically compensated from the agent's FLR posted as collateral, plus an additional 1% to cover the transaction costs in repurchasing the XRP themselves. Therefore, FXRP, or indeed any F-asset protocol, as it will work similarly, ensures that no centralized intermediary is needed to allow any asset to be represented on Flare and participate in the smart contracts of decentralized applications. FTSO. Spark token and F-asset holders can also contribute to the Flare Time Series Oracle, FTSO, which ensures accurate data estimates on Flare from off-chain sources while retaining decentralization. For each time series, such as the XRP FLR price, the FTSO asks relevant participants to provide an estimate. FLR holders provide estimates for all time series, and F-asset holders just for the time series relating to their F-asset. Those estimates are then processed by the FTSO to produce an output. The incentive for F-asset holders in doing this is to ensure the safety of their application. Spark token holders are incentivized to provide data through Oracle rewards, which are the amount of FLR minted by the system. Only those who provide data deemed to be correct, closest to the output value, will receive a share of the rewards. As the FTSO requires participants to run hardware that can provide estimates every couple of seconds, not every holder will want to do so. They can opt to delegate that responsibility to a dedicated data provider, while still earning a share of the rewards. As a result, participants could earn FXRP tokens by providing FLR collateral to the FXRP protocol, as well as earning FLR Oracle rewards from the FTSO at the same time. For example, governance. The Flare network is entirely governed on-chain by Spark token holders through voting on decisions such as transaction costs, Oracle reward rates, collateral ratios, and creation or redemption fees. SDAs can also optionally request to be governed by FLR holders. As with FTSO participation, governance votes can be delegated if holders do not wish to use them directly. The non-profit Flare Foundation will then take direction solely from Spark holders to handle off-chain responsibilities including grants, investments, research and development, education, publicity, and partnerships, with transparent reports regularly published. The Coston Testnet. Coston is the public testnet for Flare, designed for developers to test applications that utilize XRP with Flare, as well as the functionality and smart contract capabilities of the Flare network, before risking actual value. Coston models FXRP functionality, though in a more basic way, to give developers a methodology for building and optimizing applications that account for the interaction between the Flare network and the XRP ledger. Like Flare, Coston is structured as a network running a customized version of the Avalanche consensus protocol while leveraging the Ethereum virtual machine for smart contracts. So what's next? A pool of 45 billion Spark tokens will be distributed to XRP holders who participated in the December 2020 snapshot following launch. 5 billion FLR from the total supply has also been dedicated to the Litecoin participants, intended to incentivize community engagement and the building of Flare applications that use FLTC as well as FXRP. A general FAsset rewards pool will also set aside funds for future FAsset participation. The Flare mainnet launch is anticipated by summer 2021, with further integration of FAsset protocols and decentralized application development including DeFi, gaming, and NFTs thereafter. The verdict. Flare network is unique. From the utility fork style of initial Spark token creation, leveraging a large existing community, to the FBA adapted version of the Avalanche consensus protocol that frees up FLR for additional versatility without compromising security, and its integration with the Ethereum virtual machine for smart contract capabilities. It is achieving something very new. Combining these features allows Flare to bring together the value of all crypto tokens with the transformative power of smart contracts on a network that can scale, for the first time, for both value as well as transaction throughput. Over time, it can help to unlock the approximate 75% of digital assets that cannot presently interact with DeFi and other decentralized applications. By further connecting with interoperability and bridge protocols, it has the potential to create a trustless, interoperable ecosystem that spans the entire crypto space. Thanks for tuning into this episode of WealthKode Blockchain Knowledge Series. Stay up to date by subscribing and following our pages for all future episodes. And feel free to comment if you'd like us to delve deeper into any of your favourite blockchains, cryptos, or digital assets in future videos. See you on the next episode.